Hello students and welcome to the online lecture series. Myself Dr. S.R. Patil. I am working as the assistant professor in Department of Chemistry at the S.V.K.T. Arts, Science and Commerce College, Deolali camp. Dear student, today's session for the TYBSc student. We know that we already started our course Chemistry of Soil and Agrochemicals, and from this course we had already started chapter 2nd, that is the problematic soil and testing. Today's session we continue this chapter, and we before starting today's session we take the quick recap of our previous session. In our previous session we had discussed some introductory part about the problematic soil, definition of problematic soil, and then further we had discussed about the acid soil. In the acid soil we had discussed the formation of acid soil, then we had discussed the effect of soil acidity of the soil and the reclamation of acid soils. All these points we had covered it in our previous session. Now in today's session we continue this topic, and our today's first point for the discussion is the alkali soil. In that, first we discuss the formation of alkali soil, and after that we will discuss the reclamation of saline soil. Along with the alkali soil, in today's session we also discuss about the classification of alkali soil. We know that the alkali soil is classified into three classes. First one is the saline soil, second one is the saline alkali soil, and third one is the non-saline alkali soil. So, dear student, in today's session we covered all these points one by one. The learning objective of today's session: after the today's session, students should know about the roles of agricultural chemistry in our day-to-day life. We also know about the scope and importance of the agricultural chemistry. After the today's session, students should know about the different types of alkali soils and also about the reclamation of alkali soil. So let's start with the first point, alkali soil. In the alkali soil, first we discuss about the formation of alkali soil, how the alkali soil is formed. We know that these soils having pH greater than 7, in that the calcareous soil gives alkaline reactions mainly due to the presence of calcium carbonate and the magnesium carbonate, while the alkaline soils are one whose alkalinity varies with the predominance of sodium salt in the soil solution, or the presence of the sodium clay, or in the presence of both. And they are formed in the low rainfall and the high evaporation regions. We know that due to the low rainfall they have the downwards and upward movement of rainwater, and due to that, which helps in the accumulation of salts in the surface layer of arid and semi-arid regions. In this formation of alkali soil, there is a second point. These soils also available in the semi-humid and the temperature region also, especially where the drainage is defective or where the underground water table is high or close to the surface. Under mild condition, the soluble salts formed by the weathering of rocks and the minerals are carried down and removed with the drainage water into the stream and finally to ocean. This is the defective drainage system. In case of the defective drainage, they accumulate at the lower layer and makes the soil alkaline. Then high water level also makes the soil alkaline. We know that alkaline soil are also found on the sea coastals where the tidal water floods and the land periodically and deposit their salt. In the alkaline soil also formed by the artificial way, and that artificial alkaline soil is produced when the canal water is used for the irrigation purpose, also due to the movements of salt between the layers. Then the seepage irrigated water or irrigation water gets waterlogged in the lower laying tract or the valleys and produces the alkaline soil. This is the artificial process how the alkaline soil is formed. In some cases, the alkaline soil results from the irrigation water itself having an excess of the soluble salt, as in the case of soil water wells or due to the canal water passing through the saline region. These are the different regions from which the saline soil or the alkaline soil is formed. In that, some natural one and some are the artificial one. Next important points regarding to alkali soil is the reclamation of alkali soil. This method depends on the type of alkalinity. First is the reclamation of saline soil due to the removing excess of salt either by the scraping the salts from the surface, or there is another way by washing them down into the lower layer beyond the root zone of the plants, or by the growing salt tolerant plants, or by the combination of two or more of these methods. Single method is responsible for the reclamation of soil also, or both the methods are responsible. By using we can done the reclamation of the soil. Reclamation is never complete in the soil in which the colloidal complexes are sodiumized. The best method of the leaching with the water having the low sodium salt content. Okay. Second way of the reclamation of the alkaline soil is as alkali soil cannot be reclaimed by the more floatings of the land, and this soil contain the free calcium carbonate content. The addition of the substance which produces acidity reclaimed the soil, like the FYM, that is the farmyard manures, then the green manure, sulfur, molasses, ions, and the aluminium sulfate, and even sulfuric acid also. Third one is the acidity developed during this course of their decompositions in the soil neutralization alkalinity, and at the same time brings the calcium carbonate into the solution, and which then reacts with the sodium clay and converts to the calcium clay. We know that fourth one of the reclamation process of the alkaline soil is the carbon dioxide liberated by the decaying organic matters and by the plant root increases the ability of calcium carbonate, due to which the concentration of calcium ions in the soil solution is increased. Then the H2SO4 also increases the concentration of calcium ions by the dissolving the calcium carbonate. The growing of the salt tolerant crops which can also withstand with the waterlogging, such as the rice, brisims. This is the example. After the concentration of the soluble salt has been sufficiently reduced to allow the growth, further helps to reclamation process. These are about the different ways of the reclamation of alkali soil. One more reclamation process, the use of acidifying fertilizers artificially, we can reclaim the alkali soils. In that the superphosphates and the amino sulfates which are used, and that fertilizers increases the acidity in the soil and maintain the fertility of the soil. It improves or weakened by the leaching and the cropping process. This by using the artificial fertilizers. Then the suitable crop rotation, also including the salt tolerant crops, helps to the reclamation process. Then we know that the crop root system, which helps in the increasing the permeability of the subsoil by exceeding the carbon dioxide pressures and developing the cracks, in which allows the percolation of the water, that increase the percolation of water. This is the process about the reclamation of alkali soil. Next point of today's session is the classification of alkali soil. We know that the alkali soil is classified into three groups. The first one is the saline soil, second one is the saline alkali soil, and the third one is the non-saline alkali soil. In this classification, we discuss here all these three groups one by one. First, we started with the first group, that is the saline soil. We know that the soil which contain the excess of sodium salt, but the clay complexes contain the excess of exchangeable calcium, are known as the saline soil. So, here we discuss about the first class, that is a saline soil. For in the first slide, we had already discussed the definition of saline soil. Now the process of accumulation of salt leading to the formation of saline soil is known as the salinization process. And the composition of soil depending upon the composition of rocks and the nature of weathering process. And these type of soils are generally containing the chlorides, sulfates, nitrates of the sodium, calcium and magnesium. Some soil also contain the potassium salt also. So in that the soluble carbonates are generally absent in such a types of soil. So this soil is also known as a white soil, and due to the presence of sodium chloride NaCl and Na2SO4 sodium sulfates, which imparts the white color of this soil. In sometimes the color of the soil is a brown due to the presence of a calcium chloride and magnesium chloride. And the pH of such a type of soil is in between the 7.5 to 8.5. ESP is a very low for such a type of saline soil. And for that ESP is the exchangeable sodium percentage. Here we calculate by using the formula. The clay particles of these such a type of soils are well granulated but not have a well developed structure. So it is a very high salt concentration and it is permeable to water and air also. The high salt concentration is harmful to the crops. We know that this is about the first group of the saline soil. That is the saline. Next group one is the saline alkali soil. We know that on accumulation of soluble salt in the soil over a prolonged period, the sodium is the predominant cations in the soil while the plant absorbs the calcium, magnesium and potassium. Sodium does not serve as an essential nutrient except for a few crops plant. It is not essential to every plant. So due to the evaporation of moisture of the soil or the absorption from the plant, the calcium carbonate and magnesium carbonate, or we can say calcium sulfate, gets precipitate and thus increasing the sodium concentration considerably due to that the precipitation. When the concentration is about 50% of the total cation from the soil, the sodium ion is replaced by the exchangeable calcium and magnesium ions to the clay complexes due to the high concentration. This is the exchange mechanism of calcium clay and sodium salt. It forms the sodium clay and calcium salt. Then the reaction is, we know that this reaction is reversible. The calcium salts are removed in the drainage water as soon as they formed, and thus making the reaction unidirectional. So the process of converting the normal soil into the alkali soil is called as alkanations. So the soil may contain the sodium clay and excess of the salt, or it may be a sodium clay with non-soluble salt also. If the soluble salts are not leached out due to the insufficient rain, then the soil contains sodium clay and excess of a soluble salt in the solution, and it is known as the alkali soil. So this soil remains the frails and possesses the aggregate crumb structures because of the presence of the sodium salt that doesn't allow the sodium clay to get disappeared. We know that the pH of such a type of soil is less than 8.5 and the exchangeable sodium percentage is more than 15%. Then electrical conductivity of such a type of soil is greater than 4 mm horse per centimeter. Then third group is a non-saline alkali soil. When the soluble salts are removed by the leaching as a result of the increasing in rainfall, okay, or it may be due to the fall of the water tables, or it may be due to by the irrigation water washing them down, or it may be for any other reason also, it gives rise to non-saline alkali soil. These are the different ways how the non-saline alkali soil is formed. So such a type of soil is contain the colloidal complex structures, or saturated complexes with the exchangeable sodium and with the insoluble salt also. The soil exchange depending upon the presence or the absence of calcium carbonate in the soil. So the this is the exchange mechanism, how the sodium clay plus calcium carbonate is exchanges the calcium clay plus sodium carbonate content. That free Na2CO3 reconverts the exchangeable complex into the sodium clay, and due to the low concentration of soluble calcium carbonate and also due to the presence of sodium carbonate Na2CO3, soil organic matter makes the black solution, and which is on drying forms the black patches on the ground surface with the black deposit on the soil particles. So, this mechanism or this soil is known as the black alkali soil. Black alkali mechanism, we say that the clay gets deposited in the lower level, making them imprecious, having the prismatic or the columnar type of structures, and so such a type of soil is called as the solanates. So, the process of development of this type of soil from the saline soil is known as the solanization process or solanization soil, formation of the soil. So, the soil reaction is strongly alkaline, and the pH of such a type of soil from 8.5 to 10, while the exchangeable sodium percentage is greater than 15. But the electrical conductivity of such a type of soil is less than 4, then drainage and aeration is also poor of such a type of soil. Due to that, because the deflocatings of that colloidal materials which silence the clays and chokes the soil pores, and due to that the drainage and aeration is very poor in such a type of soil. And as a result, due to that, the soil loses their crumb structures, and the presence of free sodium carbonate has the caustic effect on the plant root also. So, due to the high pH, the impressed physical conditions of the soils and the toxic effect of the free sodium carbonate and exchangeable sodium that adversely affected the plant growth, and these soils are therefore mostly barren. These are the different three groups of alkali soil. Next important point related to alkali soil is the degraded alkali soil. We know that what is meant by degradations. Then in that the nature of the changes during the soil development is slightly different when it does not contain the free calcium carbonate content, and due to that in the prolonged leaching is there, and the sodium clay hydrolyze and the liberated free NaOH, sodium hydroxide, and that sodium hydroxide which is combines with the carbon dioxide of the soil air, and that forms calcium carbonate. This is the reaction how the calcium carbonate is formed from the hydrolysis of the sodium clay. The humus get dissolved in the that formed sodium carbonate, and then solution passes down to the lower layer of the soil, and due to that which acquires the black color due to its deposition, and part of the exchangeable sodium ion is also replaced by the hydrogen ions which breaks into the salicylic acids, which are also leached down along with the humus content, and this process is also known as the solanizations, and the soil so form is called as the solids or the degraded alkali soil. In such a type of soil is acidic in nature, and the pH of that soil is 6, while the exchangeable sodium percentage is greater than 15%, and such a type of soil is very compact and having a low permeability. So, dear student, it is all about the today's session. We take the look on the summary of the today's session. Dear student, in today's session, first here we discuss about the alkali soil, how the formation of alkali soil, then the reclamation of saline soil, and then after the discussion of alkali soil, we discuss about the classification of alkali soil. This alkali soil is classified into 3 groups. First group is the saline soil, second one is the saline alkali soil, and third one is the non-saline alkali soil. So, this is all about the today's session. On the basis of today's session, we have to solve the session assignment. In the session assignment, we have to solve the first question, write note on the classification of alkali soil. In that we have to write down 3 groups of alkali soil. And second question for the assignment is write note on the reclamation of saline soil, or how the reclamation of saline soil is done by using the different processes. So, dear student, solve these two questions on the base of today's session and send me on our Google Classroom. Then in the next session, we will start our next chapter from this same course. Next chapter is the laboratory methods of soil analysis. So, this is all about the today's session. Thank you very much.